Hello everyone, and thank you for joining this session. Today I'd like to guide you through an innovative approach that can help with unstructured text analysis. But let me start with a quick introduction. I'm Federica Ventruto, Graph and AI Engineer at GraphAware. GraphAware is a leader company in graph consultancy and the creator of Human. Now, we know that we are surrounded by data every day. From the moment we wake up, we start reading emails, scrolling headlines, and reading documents and reports. And this is called unstructured data because it doesn't have a predefined format or a predefined structure. Now, according to this research by Gartner, it's around 80 to 90% of all the new enterprise data that is in this format, meaning that most of the data that is produced every day is unstructured. What's even more striking is that only about 10% of this data is stored and even less is analyzed, meaning that most of this data remains untouched and not used. And this because this data is hard to manage, but even harder to analyze. Now, my goal for this session is to provide a few ideas that can help to mitigate some of the issues that you have when processing unstructured data. And we will see this performed through entity and relation extraction. This is a very powerful process because it allows you to convert text into a knowledge graph so that you can easily navigate the content of your document and integrate this knowledge with other type of data, and of course then perform downstream analysis and predictions. But entity extraction is also very useful because this is the first step that you have to do when you want to identify and then redact personally identifiable information. Now, in this session, we will discuss only the first point, so how a good entity extraction can help the navigation of the knowledge graph and improve the results of your analysis. But if you are interested in anonymization and privacy related to large language model, I would really suggest you to attend the session that comes after mine from my colleague Christoph, and that will be a very insightful session. Now, about entity and relation extraction, we said that the first advantage is that results are already in a graph format. You can easily store the extracted entities as nodes in your graph and the relationship as links. When this task is performed by a generative AI, it is also domain adaptable in the sense that you can easily customize the prompt for extracting different type of entities and process different documents. About the disadvantages, the first one that is the most important is the over-extraction, because LLMs are trained to produce tokens, and this is what they do. If you ask to have people, you will get all the people that are mentioned in a document, regardless of the role that these people play in the document, if these are central actors or just some marginal entities. So that very often you will get a noisy and unfocused graph, and it's difficult to understand what are the central actors, the central entities, and what are other marginal details. Large language models are also have also some reliability concerns because usually you do want to check the results instead of blindly approving what is coming out of generative AI. Now, the way in which this information extraction task is usually performed using GenAI is by considering two prompts. The first one is the named entity recognition. You just provide the document and the set of entities that you want to extract with the description and examples and so on. Then for the relation extraction, you have another prompt and you pass the text, optionally the extracted entities from the previous one, and the set of relations of your interest. In general, this can be done by using a single prompt, but in this case, we are supposing that we have two of them. Now, the approach that we wanted to suggest, that we wanted to introduce in order to mitigate the over-extraction problem is slightly different compared to this one. So instead of just taking the original document and ask the model to extract all entities and the relationships that are mentioned in the document, our approach is to to add another initial preprocessing step that takes your document and extract the main narrative out of it. So the narrative is just represented by the main actors, main events, and dynamics that are represented in the document. The way in which you would tell someone that hasn't read before the document the content of it. And then our idea is to perform the information extraction task on the narrative. So in this way, you will get the focus of the model on the main things, on the main topic of your document. So in this case, we have a witness statement, and on the left side we have highlighted the entities that the LLM returned by processing this document, while on the right side we have the result of the narrative extraction and the extracted entities according to the LLM. So you can notice that all the entities related to the incident are still on the narrative. For instance, the date of the incident, the name of the witness, the location, details about the offense, and the car that was involved. What is missing are just a few details, for instance, the address of the witness, the date of the declaration, the place, and the officer that witnessed it. But in general, I would say that these are not highly relevant details, or at least are not highly relevant for an analyst that is working on this case and it is trying to collecting all the pieces related to the incident. So all the details related to the incident. Now, this is the same example, but seen from the graph perspective. So these are just the knowledge graphs that you get by processing the original text and the narrative. So again, all the details related to the incident are still here, still the same, without changing any word. What changed are just a few details, such as the address of Sarah, the location where the witness statement has been issued, and the officer, and also the date of the statement. Now, in general, as I said before, supposing that we are an investigator, these are not highly relevant details, and most of the times can just pollute our graph. Now, supposing that we are considering two different witness statements for the same incident, one from Sarah, the one that we had before, and the other one from James. This is a subgraph of the extracted information from these two witness statements. In this case, you can notice that we have 5 different locations and 4 different dates, and these are coming out of the original witness statement. Now, supposing that we are an investigator, can we guess what is the location of the incident? Why we have so many locations? Maybe we can suppose that the car stopped in one of these locations after the incident, and again, why we have all these dates. Let's suppose that we are again an analyst and we wanted to identify the temporal range of the incident, because we needed to perform an analysis of the car events, the ANPR camera events around the location of the incident. Now, if I do a query considering this graph, the one extracted from the original document, we have 9 hours of time to analyze, half a day of car and traffic events to be analyzed around the location of the incident. And this is just because in one of the statements, the Sarah's one, the date is the day after the incident. So this was shifting and enlarging the range of the analysis. While if we were able to identify only the central information, the ones that are related to the incident, so only the details of the incident, we would have that the interval is going from 3:10 p.m., the time mentioned by James, to 3:15 p.m., the time mentioned by Sarah. So just 5 minutes of time of temporal interval compared to the 9 hours that we saw before. And this is just an example in which we are considering a true witness statement. But if you consider that in general, we would have many more witness statements, and the most of the times there are also some contradictions, you can understand how an approach of this type can help to identify which are the main information that you should look at. Now, a quick recap about the approach. We start with the elaboration of a structured investigation-oriented narrative. In this case, we make our goal, our idea clear to the model. So we asked to explain the content of a document to an investigator that was working on the incident. And again, we said to produce a structured narrative that includes all explicitly stated and operationally relevant events and information. And this is the output narrative. Then we perform the entity extraction on the narrative, not on the document. Indeed, here we say to the model to extract, to only extract entities that are mentioned in the text that corresponds to our narrative. While we also provide the original document that is called context, and we instruct the model to use it only if something is not clear, if it is not able to fully qualify an entity, because in the context, in the original document, there are additional information. But the extraction has to be done on the narrative. And a similar thing is for the relation extraction. We pass the narrative from which we wanted to extract information, the original document as a context, and the extracted information from the previous step. Now, about the second problem that we mentioned at the beginning, the reliability challenges, we said that the human validation still matters. And in general, you don't want to mix what is coming out from large language models that could be not accurate enough or partially wrong with other sources of data. So in general, our idea is to store the results coming from LLMs in a sort of metagraph that is a staging area for candidates. These results will stay here until human validation. So it's the analyst that has the responsibility to approve, discard, and confirm the entities. And this can be done via this simple interface. So approve, discard, or edit an entity. What is validated will be added into the final knowledge graph. But it's the analyst that decides what is fine and what is not. So after applying our narrative extraction pipeline, we store the results in the metagraph that is represented by this part of the graph. And in particular, we used 2 node labels that are entity and relationship with their links that are only visible to analysts responsible for validating the results. This is thanks to the role-based access control. Of course, this is a disconnected graph compared to the graph that is visible to all the other users. And for this reason, you can also define a cleansing strategy for items that have been discarded or things that have not been validated after some weeks. Then, thanks to the human validation, the items will be added into the final knowledge graph, and you can finally merge and leverage the knowledge. Now, a few benefits that we identified in this approach, so that we can have a quick recap. We saw that the narrative extraction, the narrative approach improves the relevance and the clarity of the knowledge graph, because you are forcing actually the large language model to focus only on the main things. In order to achieve this step, so improve the clarity, of course, you have to define the narrative elaboration prompt in a good way, so that it's tailored according to what you want to get, the information that you want to get. And then thanks to the human validation, you are improving the quality of the results thanks to a few adjustments that the analyst can apply, and more important, the confidence in the results. Now that's it from me, and I'd like to thank you for your attention. So enjoy the rest of notes. Thank you.